So this is kind of cool. I thought I'd share this with you. So I've got some gear set up here. I've got a scope. It's not really relevant. Got a GPS outputting 1 pulse per second. Into this frequency counter, I got a couple of function generators. The bottom one works. I calibrated it. The top one, somebody fed AC into the trigger and blew up some stuff. But the counter, I finally got it counting a 1 hertz signal on what I think are all the right settings, and at the longest gate time I have to fiddle with it. This box back here is my rubidium standard, which is roasty toasty. I'd like to know how warm that actually gets. It idles at 12 watts. But so this is outputting 1 PPS, and the gate times, like I said, are about 10 seconds for this mode. So we're showing 1 hertz, so that's 1.0. So there's 2 decimals we can't see. Well, right now it's 9, so it's 1 decibel we can't see. But that would be 9.9 hertz. 0.99. Oh, so it's 1 0 0 0. So tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 100 millionths, or 10 millionths, 100 millionths, billionths, 10 billionths of a second. So we're reading down to 10 billionths of a second there. 1 10 billionth of a second. That is definitely a short enough interval that the length of this, whatever this is, 20 inches of coax is definitely impacted there. Just thinking about the velocity factor going through the copper and me wiggling it around is adjusting these readings. So that's pretty cool, having a frequency counter that can really get down in the noise for super small intervals. Look at that, almost all zeros, almost right on the dot, 1 hertz. And of course the rubidium standard helps. Though with that rubidium standard I can calibrate this guy and get its internal oscillator even better, and then I can measure the rubidium even better. And on paper, in theory, at least for short-term stability, I should be able to get the ovenized oscillator in here, within spitting distance of the rubidium, probably for like a day. So, but I'll need to do some computer control, because I'll have to actually do some statistical analysis to actually measure the noise and all that fun stuff. But something that's nice about this is I can put it into standby mode, and it turns off the display and the frequency counter, but it keeps the power supply and the internal oven hot. So, and it uses very little power when it does that, just a handful of watts, because the oven is it's a double insulated oven. It's very well insulated. The rubidium, of course, is free running. It is not tapped into the internal power, but since it only needs 24 volts, if I can find a spare 24 volts in this guy, I'd like to attach it. And the rubidium has some mounting holes on this bottom plate it's sitting on, and so I could probably actually screw it into the lid of the Racal-Dana pretty easily. And I can just wake it back up. Let's have it take another count here. Look at that. And it's really impressive that, that's a GPS receiver that, that module was $50 on a PCB, maybe, an extra $20 worth of components, and we can output a signal that is 1 hertz to within, a couple of, 10 billionths of a hertz. That's really cool. And there it is. We just see the little LED blinking away. We see the little trigger LED blinking away. But look at how precisely it's blinking.